I want to talk about a 3D modeling demonstration. So I've got, what I have, a little less than 50 minutes now to go through this. So I'm going to go really quickly through this. As I mentioned yesterday in the on the ROI of 3D modeling, there are two TxDOT Engineering Software Solutions statewide rollouts. Of course, today I want to talk to you about, as Eddie just talked to you about ProjectWise, I want to talk to you about 3D modeling, and specifically the software that's going to be implemented in 3D modeling. Now, our software that you'll hear talked a lot about is OpenRoads. And I want to just real quickly clear this up, that OpenRoads is not a product, it's a technology. So you will still run Geopack, or you can run En-ROADS, whichever one you want to run, but it's actually a common technology. It'll be the same in both. If you run En-ROADS, you'll be running this. You run Geopack, you look over my shoulder, you won't be able to tell which one I'm running. It's the common technology in all of our Bentley Civil products. And as I mentioned yesterday, OpenRoads is all about modeling. It's built to model. Over the years, we've realized our older software had some technical deficiencies when it came to modeling. And so we said, okay, let's start over. Let's build a new technology that removes all those technical deficiencies. And you'll see what I'm talking about here as I go through some of these demonstrations. Now, let me give you some general things about OpenRoads, and then I'll get to a lot of videos and really cool stuff, and hopefully we'll get some oohs and ahs and those kind of things as we go through. The first thing about OpenRoads is everything is DGN based. Everything moves into the design file. There are no external GPK files. There are no external .10 files. The terrain model becomes a MicroStation element. It moves in the DGN file. Your geometry lives in the DGN file. Your model are all DGN elements. Even your standards, your features, your AASHTO design standards, they all reside in DGN libraries. So everything becomes DGN based. Now, there's some really nice things about this. For example, because everything moves in the DGN, you get undo redo. So you change a radius on a curve, wrong radius, just undo it. You make a change to a break line in a terrain, I didn't mean to do that, undo it. So you get as many undos and redos as you do inside of MicroStation. Because you're inside a MicroStation, you've got an alignment or a civil element, you want to trim it, just use the MicroStation trim command or extend command. You can use any MicroStation commands on civil elements. It just makes everything much simpler. The other thing you're going to notice about OpenRoads is the GUI, or the user experience. I always throw, when I talk about user experience, I always throw the iPhone up there. What made the iPhone so successful is the way it was intuitive. It would intuit what you wanted. You think about, on the iPhone, you'd go and you look up a restaurant, and they thought, okay, well, if you look up a restaurant, you might want to call that restaurant. You might want directions to that restaurant. In other words, they intuit other things about what you did. OpenRoads is going to do the same thing. For example, one of the things you're going to notice right here is we create what are called context menus. So if you select an alignment, we'll actually pop up a menu with commands specifically for alignments. Do you want to look at the properties? Do you want to open a profile? Do you want to create a corridor? Do you want to do a report? And so if you select a terrain, we'll give you options for terrains. If you select a corridor, we'll give you options for a corridor. If you select an existing profile, we'll say you want to do a best fit. You select a profile, you won't get that option. We can either tell existing profiles from proposed profiles. The other thing is we do what's called heads-up prompts. Dialogues kind of move away. The dialogues are there, you can use them, but you don't have to. All your prompts are right there on your cursor, right there on the screen. And so everything's very graphical and very upfront. The other thing we're going to do is what we call inline editing. You've got an alignment, you want to change the bearing, you want to change the distance of that tangent, you just click on that number, and right there on the screen you can change that and it'll update for you on the fly. You don't have to go to a dialogue. So those are two of the real general things that we want to cover. So what I'm going to do here is I'm just going to walk through a project. Real simple, going to keep it real simple, and I'm going to start from scratch. I'm going to import a terrain. I'm going to build an alignment. I'm going to create a profile, and then I'm going to model it and just show you how it works. And then we'll kind of delve into some of the deeper aspects of OpenRoads. So I'm going to start here. I'm going to import a file. We can import point clouds. We can do USGS DEM files. You name it, all kind of things. I'm going to bring in an XML file. And again, I'm using OpenRose to do this. So here's the dialog that says import the XML file. And what it does, it creates a terrain. Now this is inside of MicroStation. Notice that I've imported it into a 3D file. The terrain becomes a MicroStation element. Because it's a MicroStation element, if I want to change the view, I can just come right inside of MicroStation and change the view attributes, and it just changes the view of the terrain. For example, if I want to do a thematic and maybe look at elevation changes, I just change the MicroStation view and the terrain automatically updates in that. So again, because it's a MicroStation element, I can just change MicroStation views and look at different things. I'm going to select it here and go to the element info. Again, because it's a MicroStation element, you can see it says it's a terrain model called ground. You can actually see all the information about the terrain, the number of islands, the voids, the features, the break lines, all inside the element info. Also inside the element info, you can actually turn the display on and off. For example, by double clicking, I can turn triangles off and contours on. I don't need civil tools for this. By the way, this is all accessible just in vanilla MicroStation. Because it's a MicroStation element, here's our context menu. You'll notice one of the options, if you want access to those displays, you get what's called a quick properties dialog that you can just bring up attached to your cursor, and makes that easy to use. Another aspect of it is because it's a MicroStation element, you can use what's called MicroStation element templates to pre-configure some setups. So for example, I've got an element template called boundary that changes it to a boundary. I've got another one called contours that automatically turns it on with contours and labels my contours for me. So you can set these all up. So here's one, you notice my contours are labeled. By the way, because it's just MicroStation, if you want to change the scale, you just change the MicroStation drawing scale. You don't have to have other preferences for En-ROADS or Geopack or anything like that. So for example, I'm going to go in here and change this to 1 inch equals 100. As soon as I do, all your contour labels just update on the fly. If I want to change it back to something else, I change it and they go back. So again, just change your drawing scale. Everything will update because it's all inside of MicroStation. We've got other options as well. For example, if you want to label your own contours, you can just go anywhere on there and strike a line. And as you move that line around the terrain, it'll just calculate the contours and label them for you as well. We've also got several types of analysis tools. For example, here's one I've set up called Drainage Design. And so I just changed that element template. In this particular element template that I set up, I've told it I want to see all of my flow areas, I want to see my ponding, I want to see all my high points and my low points. And so it just changes the display for me on the fly, and you can see all of that information on there as well. All kind of analysis tools. We can do volumes. We can do different types of drainage analysis. Here's one of the analysis tools you'll be familiar with if you've used the Geopack terrain tools. You can see as you just move around, you're getting the flow area, you're getting the triangle, you're getting the contour. You'll notice on the screen there it's showing you the X value, the Y value, and your elevation as well. We've got other tools that'll calculate slopes. For example, I've got one here. And notice when it says what terrain, I'm just identifying the graphical terrain so it knows which one I want to use as I move along that. And so this is a real terrain here. And it's right inside of MicroStation. I don't need any kind of external files. Notice these are all 3D. So I'm going to rotate this around in 3D just so that you can see that anytime we label something, it'll be draped on the terrain. So even your flow areas are all draped so you can see the different flows and everything that. So visually, it's really nice and it's really, really fast. Because it's in MicroStation, it's really, really quick and works really well. So there's our terrain that we've brought in. Now, I want to start developing some geometry. Now, my terrain is in its own file called Terrain 3D. I'm going to go over and I want to start storing some geometry. And I'm going to do that in a 2D file. Okay, so here I am in a 2D file. You can see up top it says Geometry 2D. So how do I use that terrain? How do I cut profiles or cross sections? Well, inside of, is this not running? I don't think it is. Let's back up one more time here. See if we can get this going here. See if that'll run. All right, we got some little problem here. We'll see what's going on. Are we not running here? Yeah, it should be. It ran yesterday. Can you see? My mouse is not moving either. All right, let's do this. Start it right there for me. All right, let's start the slideshow. If it doesn't run, I'll kick it off on this. Okay. All right, hold on just a second. We'll get it going here. Yeah, it should be. Okay, so we'll figure it out. Is it playing? Well, that's not good, is it? Yeah, I don't need a ooh from that.
By the way, Project
It says QuickTime not available.
Should be. Got time in here. Obviously, it ran the first one.
Try playing that one. All right, well, that ain't good. Anybody got a joke or anything they want to?
I'm not showing QuickTime.
Can you add it? Or?
Yeah. But wasn't the first video the same way?
Yeah.
Yeah, so I don't quite understand why. It's not connecting.
Yeah, because we're not, I mean, it shouldn't matter, should it?
Nope. There it goes.
Okay. Can you
Download it?
right click and play, or can you do a preview, or I just won't play it? If I get out, now right click and say preview. Yeah, see, it's your QuickTime.
Yeah, that's unusual.
All right, so I'm going to talk
Yeah.
while they're trying to fix it. All right, so let me explain a couple things. Because everything moves in the DGN file, anytime you want to use something, you just reference it. Okay? So think about today, you've got a GPK, and you have to put all your geometry in the GPK. Well, in the new Open Roads, how you configure your geometry is up to you. If you want to put all your geometry in one DGN file, that's up to you. Let's say you've got an interchange and you've got an eastbound, a westbound, ramp A, ramp B. You could put each alignment in a different DGN file. And then you just reference in the alignments as you want to use them. Everybody with me? If you want to use a terrain, you just reference it. You want to get quantities from a model, you can reference it. For example, let's say you got a 20-mile project, and you want to break that up in, amongst 5 different design teams. So you want to give 4 miles to each design team. One design team could work in one file. A second design team could build their corridor in a second file, and so forth and so on. And so you could have your corridor split up into 5 different DGN files. When you get ready to run cross sections, you just reference all the corridors in and just cut cross sections for the whole job. So how you what we call federate your data, how you break it up, is completely up to you. We'll work the exact same way if data's in a DGN file, in a active file, or if it's in a reference file. We don't care. You want to get a report on an alignment, doesn't matter if you're in the alignment file or you've got the alignment file referenced. We don't care. It'll work exactly the same way. And so keep that in mind. That's one of the big pluses of data moving inside the DGN file. So one of the things I was going to show you on that video, if it would have ran, was the fact that when I'm in a 2D geometry file and I want to bring in, let's say, for example, a terrain to cut a profile off of, an existing profile, I just reference the terrain. That's how I get access to it. Okay, so that's one of the new things you'll kind of have to get used to, because you won't have all these external files like GPKs and TINs and things like that. Everything will be DGN. Everything will be DGN based.
It's not letting me do it.
Not good?
Nope.
Okay. All right. Well, Well, we're going to get through this 50-minute presentation real quickly then. Okay, all right. So we don't know what's going on with the videos, and so hopefully we'll get these straight. The presentation itself is ready to go. He's just not QuickTime or something's not playing, so we don't know why. But when you get these, be sure and run through these videos. They'll kind of show you how all this works and everything. And so I'll just run through them. Okay, I'll talk over it as it won't be near as exciting, and maybe some of them will run. Here's one about design standards. So one of the new things you have in Open Roads is the ability to set up all your design standards. We deliver with Open Roads a Bentley Civil Imperial and a Bentley Civil Metric workspace, which we deliver all the AASHTO design standards. And so as you begin to design an alignment, you can say, I want to design this alignment according to this design standard. And so as you're designing, the software is watching, and so if you've got a radius less than minimum, it'll flag it for you. And in fact, the way it flags it is it actually puts a graphical, what we call an aeroglyph, on the alignment. And it's a little triangle with an eye on it, and it says you got a problem with this curve. And if I actually hover over that error, it'll pop up and tell me what the error is. And that aeroglyph will stay there until you solve the problem. Now you go change the radius and it'll update. And so that's all the design standards. By the way, you don't have to necessarily have to design. If you come in here and you, for example, have designed an alignment and you didn't apply a design standard, you can do it after the fact. So you can say, oh, I forgot to do it. I need to go pick an AASHTO 2-lane, 6% super, 50 miles an hour, apply it to that road. And you select the alignment, it'll apply the design standard. If you got any problems, it'll pop up error message and say you got issues with these curves, you got issues in these tangents. And so you can do it as a pre-design methodology, or you can do it as a post-design methodology. By the way, everybody know how MicroStation works today. For example, you have level libraries. So you'll open up a file and maybe you create something on a level. It adds the level to your file. Open Roads works exactly the same way. Every time you do something like you use the design standard, we add the design standard to that file. So if you pick that up and send it to a colleague, they'll have all the information they need. They'll have any templates that were used, any design standards that were used, anything across the board. By the way, I was hoping you guys could see this because you're going to really appreciate the stationing. When you place an alignment with Open Roads, it will station it automatically. The stationing is just automatic. You don't have to go do a secondary thing. It'll just station it. If you change this road in any way, for example, you were to extend this end, the stationing will update. You can actually, if you want to change the stationing here from beginning station from 140 to 130, you can actually select the alignment. A little box will pop up and you can just key in a new station right there on the screen and it'll restation it for you. So the stationing is very dynamic. You don't have to go like the DNC manager and station it and then somebody says we need to change the station. Well, let me delete it and re-update it. None of that stuff anymore that has to be done. Yes? It's down at the thing at the booth. You can try. Okay. Yeah, it's good stuff, but we're gonna probably run out of time. Vertical geometry. A couple things about vertical. I mentioned yesterday in the ROI of 3D modeling that you can work in 2D and 3D. If y'all were there, you remember that, right? It's called design time visualization. One of the things about this, I can select this alignment. A little context menu pops up and I can say open my profile for me. It'll allow profiles in Open Roads actually have their own views. You don't have to actually go and say I want to plot a profile. You just say open a profile view. I can select, for example, view 7, pop it up, hit a data point, and my profile, my existing profile will display. By the way, the existing profiles are dynamically linked to the alignment. So if you go to that alignment and actually pick it up and graphically move it, you'll watch the profile move in the profile view. So if anybody changes the alignment, changes the curve radius, say from 1200 to 1500, the existing profile will update automatically. You don't have to tell it to update. By the way, if anybody updates the terrain on you, the existing profile will update automatically. You don't have to go recut it. It's a dynamic profile that's linked to the alignment and to the terrain as well. Corridor modeling, I really wish these would run. They're just so cool. What we can do here is I've got a 2D view over on the left. I've got a 3D view over on the right. Basically what I can do is select the alignment. I get a context menu pops up. It says I want to create a corridor. It says, okay, what do you want to call it? What template do you want to use? I can hit the Alt down arrow on my keyboard. The template library pops up. I choose my template. It says how often do you want to drop it along that alignment. I can say every 5 feet, every 10 feet, and then boom, it'll put it in 2D. You'll get all your 2D planimetrics. You'll get your edge of pavements, your back of curves, your bottom of ditches, whatever you want. And then, of course, over in 3D, you'll automatically see that as well. And so, again, any changes to your profile, one of the things this video will show you, I'll open up a profile view. I'll change an elevation on the profile. Boom, the model will update automatically. I'll come over here and change the starting station of my template drops. Boom, the corridor will update automatically. So everything is dynamic. Everything is very automated and automatic as it goes through there. Now, one of the things, and so what those first videos would do, hopefully you'll get to see them at some point, we'll walk you through just some of the basics. This is how it works. Now, what I want to do with the second part of the presentation is kind of talk about what sets OpenRoads apart. Yes, the user interface is a lot easier to use. Yes, it's DGN based, which simplifies everybody's life. Don't have all those external files. But what really sets it apart? What makes it different? And one of the things that sets it apart is what we call parametric design. What parametric design is this. As you're designing, OpenRoads is watching everything you do. Okay? You know, you go in, for example, one of the examples I use is this one here. We've all done this in MicroStation. You go into MicroStation, you've got a line, let's say you've got an alignment, and you want to create edges of pavement, right? So what do? You copy parallel. You say, I want to copy parallel 12 foot left, 12 foot right, 24 foot left, 24 foot right. And then somebody comes back and moves the alignment. And what do you have to do? Delete those lines and go copy parallel again, right? With OpenRoads, you don't have to do that. With OpenRoads, if I say I want to offset parallel from that alignment, when you do that, OpenRoads remembers it preserves a relationship between the edge of pavement and the alignment. It says, oh, you want those edge of pavements to be 24 foot from that alignment. So if somebody comes back and changes the alignment, guess what happens? The edge of pavements will move with it. It's called parametric design. So it's this idea that we preserve these rules and relationships that you're building as you go through this design process. So if you change one thing, we'll update the whole thing. For example, I got a video here that shows this really nice. If you come in here and let's say I've got edge of pavements for the side road and I've got an edge of pavement for the main line, and you tell it you want to put in a curb return. So I say I want a curb return in here of 25 feet. And it says, okay, well, how do you want to trim those? Do you want to trim those up nice and pretty? And you say yes. And so it creates a curb return and it trims. If you come in and change that curb return radius, say from 25 to 50, it'll update the radius, but it automatically does all the trimming. Everybody with me? In other words, it remembers that relationship. So think about this. If these edge of pavements are in relationship to this center line, these edge of pavements are in relationship to this center line, the radiuses are in relationship to the two edge of pavements, what would happen if somebody came back and said, I need you to move the whole intersection? The whole thing will move for you. I mean, everything just move up and down. And so it's all about parametric modeling. This is, again, an example of that. What I do here on this one is I actually just create some geometry. I create edge of pavements. I put in some return radiuses. I pick up that alignment, move it down a little bit, and when I do, the whole thing updates on the fly. Because it's all in relationship to one another. That's one of the things that really sets OpenRoads apart. Here, and this all works. Here's one. Hey, hallelujah, it's going to run. Here's one, a 2D. Down here, I've got a cross-section in 3D. And I'm going through this median with a turn lane here, right? Notice as I'm moving through, you can see the cross-section updating. Now, this whole median here is in relationship with itself. It's all parametric. So let's say you can see all the little values here on the screen. So let's say my project manager comes back and says, I need to lengthen, this is a 75-foot storage lane, I need you to change that to 100 feet. I click on that value, change that to 100 feet, and you'll watch the whole median just update on the fly. I mean, that's cool, right? I mean, that's only one video. But that's what parametric design is. You know, in other words, this whole thing is in relationship with each other. The radiuses are in relationship to the tangents. They're in relationship to the center line. If I come back over here, you can see here's an offset. So I say, well, I want to change that offset value for that. Make that change with inline editing right there on the screen, and you'll notice everything just updates. Because these are things in the past we'd have to delete elements and replace elements. You don't have to do that anymore. Open Roads is remembering how this thing was built, and everything's going to update, the 2D, the cross-section, and even the 3D. So this is what kind of sets Open Roads apart. You see, the fact is, when I talk to people about software, everybody wants automatic updates. Everybody says, you know, one of the biggest issues with my job is that I'll do all this work and somebody comes in and says, you got to make a change, and then I have to go back and I got to redo. I spend hours redoing that intersection, or I spend hours redoing that median. You don't have to do that anymore. Do it right. Do it with Open Roads, and we'll update it. So what happens is the software, in order to update correctly, the software has to remember your engineering decisions. It has to remember what we call design intent, and that's what Open Roads is designed to do, to remember what you're doing. I've got this thing here. It says, okay, because I always get this question, well, how does the software, how do I communicate? Is this like telepathy or something, or is there a real way that I can communicate to the software? Now, sometimes you don't have to do anything. For example, if you offset parallel, the software says, oh, well, I'll remember that for you, right? I mean, that makes sense. So sometimes just the command you use is telling the software to remember what I just did. That works pretty easy. But there are other options as well. For example, many of you may be familiar with AccuDraw inside of MicroStation. In Open Roads, we have a new version called, we've civilized AccuDraw. And so we call it Civil AccuDraw. So it's AccuDraw, but you can put in stations and offsets and all kind of really neat things that you can do with it. And AccuDraw becomes a pretty important tool for you as an engineer to communicate to the software what you're trying to do. I wish this one would run. This is a really good example here. I've got an interchange here that, an intersection that 2D, I just designed it real easy. And what I do is I can pick up this line right here and just move it up and down this road, and the whole intersection will just dynamically move. I mean, it's real cool. And then what I do is I say, okay, that all works great, but what would happen if you need to put in a stop sign? Right? Now, most people, when they go do, for example, stop bars or curb cut ramps or a stop sign, what we do is we figure out where that needs to go, right? We've got some kind of standard that says stop sign needs to be this far back from the stop bar, et cetera, et cetera, et cetera. You want to change that out for me, if you don't mind? So what we do is we go in and we locate that stop sign, and the way we locate it is using station and offsets. All right, now everybody listen to me real quickly here. Open Roads is a paradigm shift in the way we do design. For years, we've done design, and it's all been based on 2D plans. Everybody with me? And the way that engineers communicate, whether you realize it or not, the language of engineers is stations, offsets, and elevations. You don't even realize you're doing it, but that's the way we communicate to other people. Where's that at? Oh, it's at station 1400 and it's 35 feet to the right. You don't need to do that anymore. In fact, that ends up being, I hate to use the word dumb, but I mean it in a good way. It's dumbed down. There's no intelligence there. For example, if I put in a stop sign at a certain station and offset, and then I go move the intersection, the stop sign's just going to sit there and look at me. Right? Because I said you belong at a certain station and offset. So I move the whole intersection, and the stop sign just sits there. So what Civil AccuDraw allows me to do is say, I want the stop sign here, but I want you to be 12 feet back of the stop bar, and I want you to be 25 feet to the right of the edge of pavement. And it creates a rule for the stop sign to say, hey, I want you to stay in relationship to this stop bar and in relationship to the edge of pavement. Now when you pick the intersection up and move it, guess what? Stop sign will move. The stop bar will move. Your curb cut ramps will move. Everything will stay in relationship to that thing there. So, all right. So design intent becomes very important in open roads. Ways for you to tell. I'll go through a couple other things. For example, snaps in microstation become very important. I'll give you an example. Today, when you go out and you lay out a corridor, how many here have used Roadway Designer in En-ROADS or Geopack? There's a few. One of the things you're going to do in modeling is you're going to take a template and you're going to run it down a road. You're going to say, I want to drop this template every 5 feet or every 10 feet, whatever that's a good rule of thumb is every 5 or 10 feet. But you'll also want to pick up what's called key stations. For example, you may have a culvert crossing that falls in between those 5 or 10 foot increments. You may want a template drop there. We'll automatically pick up things, for example, we'll pick up all your critical points, your PCs, your PTs, your PIs, both horizontal and vertical. We'll pick up all your super elevation break points. We'll pick up all those automatically. You may have, for example, the beginning of a wall. When you're modeling, today when we do cross sections, think about it. You run cross sections down a road at 25 feet, you might get one cross section in the middle of a wall. But when you model, you want to pick up a template drop at the beginning of the wall and the end of the wall to make sure you've got it modeled correctly. These are called key stations. So you can just say, hey, I need a template drop here at a key station. Again, most people, the way they do key stations is they put in a station. They say, I want a key station at 100 plus 03.45. But with open roads, you're not limited by that. For example, if I want a key station at the PC of a curb return, when it says where do you want it, instead of just keying in calculating the station and keying it in, I can snap to the curb return. Everybody with me? Okay. When you snap to the curb return, let's go up here. Okay, so I've got this one here. Okay, hold on just one second. Okay, so what happens is when you snap to the curb return, you're telling the software, I want you to calculate the station and add me a template drop there, but I want you to remember that I snapped. So later on, if your project manager comes back and says, hey, we need to change that from a 25-foot radius to a 35-foot radius, and the radius moves and the PC of the radius moves, guess what? The key station will update automatically because it remembered you wanted it at that. So snaps become pretty important as well. And this is a video here. Again, it's not running, but it actually shows that process. Template drop. This is a cool video. I go in, I'm going to place a corridor along this alignment. And it says to me, where do you want to start? And I said, we'll start at the beginning of the alignment. It says, where do you want to end? And normally when it says, where do you want to end a template drop, we key in a station, right? That's how we communicate. But you can actually say, well, I want to snap to some object in the file. For example, let's say there's a wall up there, and I want to snap to the end of that wall. Again, that tells the software, oh, you want this template to stop at the beginning of that wall. So if later on, if structural design comes back and changes the wall, guess what your template will do? It'll move automatically because you told it, I want you to be, you know, tied or in a relationship with that wall. Microstation commands are another one. You can use trim and extend. I use a real simple example here. You can see here I've got an intersection. I've got a front of the crosswalk that I've snapped to the PC of the curb returns. I go in, I do an offset parallel, 8 foot back, so I'm going to put in an 8-foot crosswalk. But what happens is when you change the radius and that thing moves, the back of the crosswalk extends too far past the edge of pavement on one side and too short on the other, right? In other words, it stays parallel, but it doesn't trim. You can use microstation trim command. So I tell the microstation, okay, trim the back of the crosswalk to that edge of pavement and extend it to the other. If you do that, Open Roads will remember that for you. So no matter what you change that radius to, microstation or Open Roads will always trim that line for you. It'll just remember it. It doesn't care. Okay, so microstation commands become very important. The other thing, and there was a couple of videos here that I was hoping you would see. I don't know if they're going to run or not, but one thing that we do is we say modeling is modeling. When you get in that file and you get ready to model, we've got all the tools that you need. If you've got a corridor, I was talking to somebody yesterday that did a preliminary design of an alignment, and it was 600 and something miles. If you've got an alignment that's 600 miles long, by all means, do a corridor, right? Say, I want you to start at the beginning, I want you to drop a template every 10 feet, and I want you to model the whole thing. That's great for corridors. But what if you've got a short piece of road, like a driveway? Corridors don't help for that. It's like trying to drive a nail with a screwdriver. Corridor tools don't work for that. What if you got a park and ride? Corridor tools aren't good for that. What if you got a pond? Corridor tools aren't good for that. We're going to give you the tools you need to model, whether it's an intersection, a park and ride, whatever it is that you need to do. This is an example here, and again, it's not going to run. I wish it would. Where I actually go through here on the east-west alignment here. This is a corridor, and so I lay that in there using corridor tools to say drop me a typical or drop me a template every 10 feet. Boom, it's done. And then I come in and I begin to model the intersection. And so what I do is I create the edge of pavements. Once I've got the 2D done, I create a profile of the alignment. Open Roads has got some really, over the years we've learned a lot of lessons. For example, one of the things this video will show you, I'll use a corridor tool to place a corridor or a model over in 2D, and you'll get it in 3D. Everybody with me? Y'all seen that hopefully at least one time already. The model shows up. When I come over and I just begin to design the profile for that side road there, I want to match the slope of that main road. Everybody with me? I want to tie in. So the profile tools have a new tool called Quick Surface Profile, and I can say, hey, find that, I can actually ID that pavement surface in 3D, and it'll project that surface as a line over onto my little intersection profile, so I can actually see visually where that surface is that I need to tie into, which is pretty nice. And that's not all. When I get ready to draw my new proposed profile, if I snap to that, guess what it tells it? It tells Open Roads, hey, I want you to remember that I snapped to that. So if somebody comes back later and adds super to the main road, that side road will actually update on the fly to match the super of that road. It'll remember those relationships. It's called design intent. A couple new things we can do. I would have definitely got some oohs and ahs out of this. In the past, we could apply a template along a corridor, right? Today, you can apply a template to anything. If you have a surface, so what we do is we build a pavement surface out of that side road using the edge of pavements and the center line as brake lines. We say, build me an asphalt surface, so it builds the top surface. You can apply a template to a surface. So if you've got a parking lot, you designed a parking lot or an intersection or a driveway, and you've got the top surface of that, you can go to a template that's only pavement, and you can say apply pavement to a surface, and it'll put all your pavement layers under the driveway, under the side road, under the park and ride. So you can apply a template even to a terrain, which is absolutely new. Nobody else can do that. The other thing you can do after I've designed that, you can apply templates. We have what are called linear templates. If you've got just a template that's, let's say it's a utility strip with a sidewalk and a slope, and you don't want to apply it around the curb returns, you can apply little templates around curb returns. Or you can apply any line that you've got, you can apply a template to it. It doesn't have to be an alignment. It doesn't have to be a corridor. So you can basically just model and build any way you want to build it. So what we did in this video is I model it by hand. I go through and show you some of the really cool tools that you can use. And then we've got the big one that we've got. We've got a new technology in Open Roads called Civil Cells. And some of you may have heard of this. Everybody knows what a cell is in MicroStation, right? The reason we have cells in MicroStation is because you have trees or you have manholes or you have fire hydrants that you're going to use over and over and over again, so you store a cell. Well, we began to ask ourselves, well, what if we had an intersection that you wanted to use over and over and over again? Why can't I design the intersection and then store that off as a civil cell? And then on my next project, just say, boom, pop that intersection in there. You can store civil cells. You can store all your roundabouts as civil cells. You can store intersections as civil cells. You can store medians as civil cells. You can store. Just to see if I could do it, I took designed an entire diamond interchange, stored it off as a civil cell, went to a new file, took 2 alignments, and said, pop that interchange in there. and it popped the entire, and modeled the entire interchange with one step, okay? So anything you want to model, you can save it off as a civil cell. Question?
Yeah, once you do that, if you want to modify it in this project.
That's right. So the beauty of it is, and this actually, man, I wish this would show. This is killing me. The beauty of it is that when you bring it to another area, or another project, it retains all of its underlying intelligence. So let's say, so for example, you only have to build one basic T intersection. And maybe when you build it, it's got 12-foot lanes and 25-foot radius returns. But on another project, you can drop it, it pops it in there, and then you can say, well, this one actually has 24-foot lanes and 35-foot. You just change the radius returns, and the model updates. So it retains a difference that makes it a civil cell as opposed to a microstation cell, is that it retains all that underlying intelligence. Okay, the pretty little lady here is telling me I got to cut it down. And so anyway, oh, look at here. Okay, this is going to work. All right, so here. All right, I'm going to model that road here. I'm going to show you this. This is, at least I get one, thank the Lord. I'm going to create a corridor for that east-west alignment. And so I'm going in there, it says how often do you want to drop it? I'm going to say every 10 feet. Notice I've got a 2D view, and over here I've got a 3D view. Now I've got this side road here, and it's a kind of a long side road, and I said, okay, I want to use a template for that. So I select my context menu, say I want to create a corridor, choose the template that I want to use. I've already got one by default. And it says, where do you want to start that? So I'm just going to leave a hole. Because I'm going to need an intersection there, so I'm just going to put a data point out there, and I'm going to model a corridor here, and I'm going to leave a hole. Now watch this. I've already got a T intersection designed in my library. So in order to place this intersection, I'm going to come over here to my task navigator menus. I'm going to come down to civil cells, and I'm going to say place civil cell. I've got, by the way, we deliver all these with the Bentley Civil Workspace. I'm going to come in and choose from my DGN library. Notice I've got some intersections. I've got a basic T. I'm going to say OK. It prompts me and says locate the side road alignment and locate the edge of pavement of the main line that you want me to tie into. And so it's going to come out there. It's going to put these little blue lines in there and says, is this the way you want it configured? I'm going to say yes. Now notice the slopes of the main line are going underneath the intersection. Everybody see that? It says, do you want me to clip that out for you and make it real pretty? I'm going to say yes. I identify the corridor I want it to clip, and it drops the intersection, merges all the side slopes and everything in there for me on the fly. Now notice I've got a hole here. How do I close that up? I just select that little element in 2D, pick it up, move it up there, snap to the back of the interchange, to the intersection, say OK, and your 3D model will update all the, it just moves it up there on the fly. So in about 5 minutes, I've designed my east-west alignment, I've designed the side road, and putting in a civil cell basic T intersection, I've designed that whole road. Thank you. I at least got one out of there. I appreciate that. All right. Real quickly, we have something to, we know that the whole idea of this is to get it to construction. So really built into open roads is these concept of something called design stages. I can select that project and say turn off these 3D components and give me line strings. Because that's what contractors want. Give me 3D line strings. And then I can export that out to a DGN or a DWG, send it out to a contractor. They can bring that into AgTech or whatever software they may be using.